Well, people have waited for so long for the NPR motor, and you guessed it's still not ready, because here's one of the prototypes. It's my test motor. It's different type of motor drive, but I'm testing with this to save the connectors on the final motor, because those motor drives are expensive and these are not so. And I have lots of extra ones of this. I am not testing the shutter parking, but basically the single frame feature. And so here's the prototype. It's all the electronics of the NPR motor except the one display and buttons module, but other stuff. There's stuff on the other sides of the circuit board, so it's not for reverse engineering. There's lots of more parts than shown here. So this is basically all my previous motors have used some kind of factory-made PLDC controller, like these Chinese ones. This is, you can check eBay. This costs like $4 or $5. This was the only one which was available during COVID, so I had to use this because there was nothing else available. But these have proven to be pretty reliable. I have never got any complaints from people using these. So the idea of this is because it's, you can see there's with 3.0 version and this is 3.1, and slightly modified the trimmer sweeper taken off, and then 0 to 5 volt pin goes to the crystal controller, like stuff like my 10-speed motor and 4-speed motor and so on. So this is can be bought as spare part. And this 3.1 model needs tiny modification. I don't know if you can see, but I have removed one of the tiny resistors near the connector. Maybe you can see it, it's there. So that is needed, and then the trimmer sweeper taken off. But here's the FET bridges and the MCU and the software on this is pretty challenging to make. Actually, it needs to work really fast, really accurately, and it's kind of, the theory is not complicated, but the practice is. So that's why I reserved so much time for the NPR motor to make, and on this one I had to make everything and all by myself, and I'm still finishing the software. And I might change this board a little, so there's the IGBT bridges and everything underneath, and there's MCUs, and this MCU board is running the display, and there's another stuff and everything. I still haven't fully tested the electromagnetic interference stuff. And here's the power board, but there's the I/O module and other stuff, and all this booster. This is actually factory made part. I managed to find just the right one to make this run at 12 volts also, but still finishing the software and checking with the oscilloscope, and then it doesn't work, and why it doesn't work, and then doing it again and checking again, and thousands of tests. But this single frame feature is a bit noisy. I can make it, here resonance. It does work. So this is running. There is no factory-made part except the voltage booster. So everything else is myself designed, and also the software, everything. So you can see this single frame feature is extremely important because it's needed for shutter parking also. And with factory-made process controllers, I couldn't make the shutter parking feature reliably. So, and no single frame also. So there's basically stepper motor controllers available, and then brushless controllers meant for running at high speeds, but nothing which combines those two. So, and is so reliable that I can use it for shutter parking reliably. So I can show you again. So I didn't meant to actually show any of these tests, but it's practiced so much later. It's maybe a good idea to give people something to see at least. So this does work, and this is reliable. I can make it tiny bit lower noise. The reason why I haven't assembled the final motors yet is because I can make this run at 24 FPS reliably, but the higher speeds than that are, the starting is not good, so I need to change the software pretty much. So I now have the single frame testing software loaded. So I'm making the software in tiny pieces and then stitching those together when the individual pieces are checked and tested, so thoroughly that I know that there's no bugs in them. So this only has the single frame software now uploaded. But anyway, for higher frame rates like the 75 and 50, I need to change the software so that it's alternating between two different running modes. And I haven't fully tested that yet, but it might take something like 2 weeks, 3 weeks even. So, and I do need that for the 4-speed, 3-speed model. It actually has like 5-6 speeds total, but anyway, the 3-speed NPR motor does need at least 33.333 FPS, so I still need the newer version of the software. And the display software is, which I'm pointing this board because this is running it. So that's running the OLED display, which is on this panel, which has wires going into the huge stack of parts. Yes, that one. So this one is running the display, and that software is finished. I just need to finish the motor control software fully before I can set the frame rate info here. So that's, well, I showed you the single frame, how it does work. And I added the pause for between every frame to show that it does stop at exactly the same position. That's needed for a single frame, and then 1 FPS constant running is, of course, doesn't have those stops. But this would allow time-lapse shooting if I do manage to have time to code that feature. But I will concentrate on the high speeds now, because I do need the motor controller switching between those two different running modes, so that it can reliably, if it starts to drop the frame rate, then it can first of all it needs to speed up to that high speed, and then it needs to maintain it, even if there comes lots of friction, then the frame rate would stop, but it needs to correct that back to the target. So I needed two different running modes, which it alternates very quickly if needed. So still working on that. Single frame works. Display does work because it's based on the atom counter, actually. Where is my atom counter? Everything is covered in dust because I'm so busy working on the software that it's full of dust. You remember the atom counter? I was made lots of videos of this. So the user interface is based on this. It's very similar. That's intentional because I saved so much time and resources by using this software as basis for the NPR display software, because the counters and counter saving and everything, those are the same, and the display layout and everything. So why make those again out of scratch when I did have a finished version on the atom counter? So this is using that software modified. What I'm doing now is finishing the motor control software, and I might make tiny changes to this circuit board. This is pretty much final, but this might need changes. And again, no reverse engineering. This is a prototype, and I'm not showing all of it, only about half. You can see most of this board, but this is really basic. So TCXO oscillator and MCU, voltage regulator and stuff. Really basic, nothing to copy from. This is quite a bit more complicated than most of the parts are on the other side. So you can see it's kind of similar package MCU, but yeah. You can make your own if you want. It's still, this is difficult to copy and the software takes maybe 2 years to figure out. So yeah, single frame works. Uploading the normal speed software 24 FPS next, and then testing that more, but we'll continue on the running mode tests. So it's advancing, but not at the pace I hoped for, but at least I have some of the features working already, and there's very little work on the display. I can show you how the display works, some other videos, but I want the motor control software to have all the pieces stitched together so that it has the functionality to work with the display, because I'm testing the software blocks individually. So that's why I don't usually show prototypes, but it's been so long that I just wanted to show you something at least. And again, it's interesting to show stuff running. Let's rotate it that angle so that it's easier to see. No, it was that angle. Yeah, anyway. Starting this 1/4 turn. But this works exactly similarly on the another type of motor drive. There's no difference at all. So I'm just using these motors to save the connectors on the final motor. So this does work. And it's reliable. I can make it tiny bit lower noise, but I will need to check with the final motor if that's necessary. This works more solidly at higher speeds. So if you're wondering what I have done for the almost 2 years, this is part of it. Trump ruining the world economy took almost a year off because I didn't manage to cover the funding gap on this project, but that's at least it advancing now pretty quickly. So it may take 2 weeks, at most 3 weeks to have the 3-speed models assembling, but I would say at least 2 weeks. Not over 3 weeks. I will take some features out, then maybe if it takes longer, but yeah, anyway. Looking good. This is final. This is final. I will think about what I will do with this, but this does work, but I can do better than this. So I would say maybe 3 weeks. We have the single frame and shutter parking at least.